Hi, my name is David Bosnich. I'm a senior software engineer on the O3DE Systems and Platforms team, and today I'm going to give a presentation about input systems in O3DE. Input is the thing that differentiates interactive experiences from all other entertainment mediums. Regardless of genre or platform, every game is driven by some form of player interaction with a physical input device. But there are lots of different input devices, each of which produce different input data, and the way this data is delivered to an application is rarely consistent across different devices or platforms. As a cross-platform game engine, we want to provide platform-independent access to input data from any input device using common interfaces that should be easily extensible in order to support new types of devices and data. In this presentation, I'll be giving an overview of O3DE's AZ framework input system and demonstrating how to use it from both C++ and Lua. I'll divide it into three sections. First, I'll go over the concepts of input devices and input channels and walk through some of the C++ code that defines these. An input device is hopefully pretty self-explanatory, for example, a keyboard, a mouse, gamepad, touchscreen, etc. And an input channel basically represents a single input source from an input device. For example, the spacebar key on a keyboard, the left mouse button, the right trigger on a gamepad. These are all examples of what we call input channels. Secondly, I'm going to show you how to obtain input data. And there are two ways you can do this, either by polling for the state of an input channel or by listening for events that get sent when the state or value of an input channel changes. I'll show you how to do this from a Lua script, although the same concepts apply from C++. Also, while most input channels produce data that can be represented by a single value, I'll touch on input channels that support arbitrary custom data structs, for example getting the position of the system mouse cursor. Lastly, I'm going to demonstrate how to set up and use input contexts and input mappings from the O3DE editor. Input mappings are basically a way for you to map different input channels to new user-defined input channels. So you can write game logic that works interchangeably with different types of input devices. For example, you might want the character to jump when you press either the spacebar key on a keyboard or the A button on a gamepad. And input context is essentially just a collection of input mappings that give you a convenient way to activate different sets of mappings depending on the in-game context. For example, you may have different input contexts active when your player character is running around versus driving a car versus flying a plane. Okay, that's the intro and the agenda, so I'm now going to jump over and start sharing my screen for the rest of the presentation. The input system used by O3DE lives in AZ framework input, and for this first section I'm going to concentrate on input devices and input channels. Most of the files have pretty extensive documentation if you need to dig into the details, but I'm going to run through writing some code to implement a new type of input device, just as an example. When implementing a new input device type, we want to inherit from AZ framework input device. Now, every input device needs to be uniquely identified by an input device ID. An input device ID is effectively a string, combination of a string and an input device index. So a string, for example, could be gamepad, and then because there can be multiple different gamepads, physical gamepads connected at the same time, they need a unique index on top of that. Not all input devices need this, but if you can have multiple connected to the system at the same time, then you'll need to utilize the index as well. So the input device ID we need to pass in to the base class constructor. So this is the name of our input device, and if we needed an index, that would be the second parameter there. But for this example, we're just going to assume there can only be one instance of this new input device type connected at once. So anything that derives from the base input device class is responsible for a number of things. Again, you can look at the documentation if you need to dive into the details. And I'm just going to go through these in our example here. Now the first thing is, well, not the first, but the most important thing that any input device implementation needs to do is return the input channels that it defines. So we need to do this by overriding get input channels by ID, which returns an input channel by ID map. This is just an alias for an unordered map of input channel instances by their ID. So to return something from this function, we'll create a private member variable, which is the map of all our input channels. We'll return that from get input channels by ID. Now we need to decide what type of input channels this new input device type is going to define. So this is the base input channel class from which all input channel types derive from. You're free to create your own types of input channels by deriving from this, but for now I'm just going to use some of the predefined types, input channel analog and input channel digital. If you do need to create your own input channel types, you can look at all of these existing examples as a reference for how to do so. So we'll include input channel analog, input channel digital. Now this is just a contrived example, so I'll have our new input device type simply define one analog channel and one digital channel. But for a real input device, you will likely end up with more channels than that. For example, if you take a look at the input device gamepad, it defines input channels related to buttons, some analog ones for triggers, and some more for the thumbstick data. Let's see this down here. So for our example, we're simply going to create one of each, an analog, my analog input channel and my digital input channel. And we need to create these in the constructor. Now, similar to how an input device must be uniquely identified by an input device ID, an input channel has to be uniquely identified by an input channel ID. And an input channel ID is effectively just a string, and then we cache the CRC32 for quicker comparison at runtime. So when we, for our analog input channel ID, we give it a unique name. This just needs to be unique amongst all input channels. And we create our analog input channel class by passing in the ID, and we also need to pass in a reference to the owning input device, which is this. And then we put that into our map of all channels by ID so that it will get returned from this function. Let's just do the same here for our digital input channel, so it has a different name, my digital input channel. Create that class and add it to the map. And we want to just make sure we clean up these when the input device gets destroyed. Here. Okay. Now that we've created our input channels and we're returning them here, we need to update them every frame to get the new state of each channel from the system. So all input channels have a process raw input event function that takes in effectively the raw value that that input channel represents. So the way that an input device updates the input channels that it owns is usually by calling this function once per frame in its tick input device implementation. So for this example, we're just going to pretend that the current analog input value is 9, so really you would get this from the system somehow, and this would be different every frame, or every frame that the input channel is being engaged by the user. For example, a trigger on a gamepad. And we are going to pass this in to my analog input channel, called process raw input event. Now this process raw input event for the input channel analog implementation uses the new value and the old value to calculate the delta, stores the new value, and then it calls update state on the base input channel class. Now this is what causes the input channel to go through its various states. So you can see here, depending on what state it's currently in and the new state, it will transition into another state potentially, or it may stay in the same state. For example, updated, this is effectively the held state if you were holding down a button. And at the end here, if we're in any state other than the idle state, we broadcast an input channel event over the input channel notification bus, passing in a reference to the input channel that has been updated. And this is the eBus that any consumer, any system that consumes input will listen to in order to receive input events when any input channel changes. Okay, so we're going to do the same thing for our digital input channel. Let's copy paste error there. So that will update the state of our digital input channel and send out events if the state has changed. So here we're just saying it's true all the time, but again you would get this from the system. Okay, so our new input device type now creates the input channels that it owns, it returns them, and it updates those input channels every time tick input device is called. Now the only other things that we have to do for a new input device implementation is to implement the isSupported and isConnected functions. Now these might seem similar, but it's possible for an input device type to be supported on a platform but not currently connected, which is why these are two distinct functions. So this leads into the fact that almost all input devices need different implementations depending on what platform you're running on. For example, gamepads, the way you obtain gamepad data on Windows is completely different to how you do it on Mac or Linux. So the way that we have solved this for all our existing input device implementations, which I would recommend doing the same if you were to create a new input device type, we use the pimple idiom by having a private implementation that the platform agnostic implementation of the input device calls through to when it needs to do anything that is platform specific. Now, I won't go into the details of how to do this, but if you need an example, you could look at any of our existing input device implementations. They all use the pimple idiom in order to call through to the platform specific implementations. So for now, we'll just say that this new contrived input device type is supported and is always connected. To wrap it up, but again, you want to look at the other examples for how these are implemented. Okay, so now that we've run through how to create a new input device type in C++ code, I'm going to move on and talk about how to obtain input data, either by subscribing to the events that get sent when the state or value of an input channel changes, or by polling the state of any existing input channel. I'll demonstrate how to do this using a Lua script, although the same concepts apply from C++. Just launching the editor here. I'm using the Atom Test project. And I'll select the mesh test level. I'm going to use the bunny as the object to attach our Lua script to. And I'm going to point this at a bunny.lua script, which currently doesn't do anything. It simply defines the onActivate and onDeactivate functions. Input events get sent over the input channel notification bus through this onInput channel event function. So to access this from Lua, in our activate function, we'll connect to this bus, which is exposed to behavior context, and in our deactivate, we'll disconnect from it if we connected. Now the function we need to implement is on input channel event, and we will now get sent all input channel events. So to start out, we're just going to print out the name of the event. This corresponds to the input channel ID, and we'll print out the device the event is being emitted from, the state of the event, and lastly the value of the event. So if I switch back to the editor and enter game mode, you'll now see it's printing out some text when I press buttons on the keyboard or the mouse with that information. For this example, I want to modify this script so that it moves the bunny in response to pressing the navigation arrows on the keyboard. So first off, I'm just going to add a couple of simple functions that will modify the position of the bunny on the x-axis and also on the y-axis. And I'll call these in response to input events in order to move the bunny. So now in our on input channel event function, instead of printing out all the info, I'm going to say if the input channel name is a left channel name, which we're going to define up here as input device keyboard, keyboard key, navigation arrow left. Now these constants correspond to what is exposed in the headers of all our inbuilt input devices. So for example, here you can see the input device keyboard defines a whole range of constant input channel IDs that are in turn reflected to behavior context, and these are the strings that represent them. So we'll say if our input channel name is the left channel name, and we also want to check that the input channel is active. Is active means that it is in either the began or updated state. Then we want to move our bunny negatively along the x-axis and multiply our move speed, which I have up there, by the delta time to make sure it's consistent with the frame rate. Okay, and I'll for now leave these debug statements in. So when we go back to the editor and enter game mode, so sorry, the debug text isn't showing there. Okay, try that again. So we enter game mode, and you can see when I press down or up or right on the keyboard, nothing happens. If I press left, then the bunny starts moving. So I'll now repeat the same exercise with the right, up and down keyboard navigation arrows, and listen to these respective events in order to move the bunny right and forward and backwards. Save that. Back to the editor. Enter game mode again, and now the bunny can move in all four directions. So that's how we can listen for input channel events from Lua. But what if instead we wanted to poll for events from our update or tick function? So one of the design goals of the AZ framework input system is that it allows you to poll for events and work with the exact same data structure as you do when listening for input events. So that is why when we send input channel events, we send the entire reference to the actual input channel class, so that when you're interacting with it to get the channel name or the value or the state, you're doing so in the exact same way as you will do if you are polling instead, where you request the input channel by its ID, for example that, and then you obtain a reference to it, and then can interact with it in the exact same way. So I'll show you how to do that now. I'll start off with a new boolean just to say whether we want to poll for input instead of listening, so we can easily toggle back and forth between the two methods. And in our activate function, if that is set to true, then we'll connect instead to the tick bus handler. Otherwise, we'll continue to connect to the input channel notification bus. And on deactivate, we'll disconnect from the tick bus handler if we were connected. So now we need to implement the onTick function. And inside the onTick function, so we're going to poll for the state of an input channel. So to do that, we want to use the input channel request bus. This is also exposed to behavior context, and among other things, this lets you this lets you get an input channel by using the get input channel function. It's an event, so you address it by the ID of the input channel you're looking to get. So we have the input channel request bus ID using our left input channel name. That will give us that input channel. So we now say just do a null check in case we happen to send in the wrong input channel ID and the channel doesn't exist or something like that. But if it exists and it is active, then we're going to translate the bunny to the left, same as here, and the delta time gets passed into the onTick function, so we don't have to get it from there like we do down below. Okay, so let's jump over to the editor and see what happens. Okay, so it's not printing anything out anymore because I was only doing that from the onInput channel event function. But when I press the left keyboard navigation key, the bunny still moves. I'll do the same thing now for the other three directions. Same concept as the left. We just get a different input channel, the right, forward and backwards ones, and move the bunny in a different direction. And while I'm here, I'm just going to throw in a few debug log statements so that we know whether we're getting input from the onTick function or the onInput channel event function. Just throw these here, the right, the forward and the backwards. Okay, so jump back to the editor, enter game mode again, and we can see when we move the keyboard navigation arrows, the bunny moves, and we're getting the debug log statements, which we just added. So while most input channels represent a single value, either a boolean on/off button or key, for example, or an analog value such as a trigger or thumbstick direction on a gamepad, there are other types of input channels that contain custom data either instead of or in addition to the single boolean or float value. So I want to talk briefly about that before moving on to the next section. Now we need to support input channels that provide additional custom data, but we need to do it in a way that doesn't burden the simpler input channels with additional data that they don't need. So the way that we achieve this is the base input channel class has get custom data functions, and it defines an internal class, base class of custom data that you can inherit from. Now this templated get custom data function simply gets the custom data from the non-templated version, and if it can be cast to the type that you are trying to obtain, it will return that. Otherwise it will return null pointer. This functionality isn't available from Lua yet, at least, but it's fairly straightforward to use from C++. Probably the most common example of where this happens is when you're looking to get the position of mouse or touch related events. So for that we have a position data 2D struct that inherits from custom data, and our mouse and touch input devices create input channels that also return one of these structs from their get custom data function. An example of where this is used can be found in the gestures gem. Gestures gem listens for AZ framework input events and it interprets them effectively as gestures, so you can set up gesture recognizers for clicks or taps, drag, hold, pinch, rotate and swipe, and these are all configurable for how the gestures are recognized. The base iGesture recognizer class in its onInput channel event function, basically the first thing it does is it checks our input channel and it asks to get custom data of the type position data 2D. Now this will be returned if it's a touch input or from a mouse, any input that has a position data 2D custom data struct associated with it. This will return that position data, and then the rest of the logic will continue using that. So we don't really need to worry at this point whether it is from a mouse or a touch event. Okay, I'm going to move on now to the third and final section of this presentation, in which I'm going to talk about input context and input mappings. An input mapping is itself an input channel, and it is designed to allow one or more other input channels to be mapped to a custom name that is set up either at edit time or even at runtime. So the example that I gave earlier is if you wanted your player character in your game to jump in response to either the spacebar key on a keyboard or the A button on a gamepad, in which case you could set up an input mapping OR and add both the spacebar key from the keyboard and the A button from the gamepad as source input channels. And when you create the mapping, you would define your custom name for it, which creates an input channel ID, so you could call it player jump, for example. And input context is essentially just a collection of input mappings, and it gives you a convenient way to enable or disable whole sets of mappings depending on the in-game context. So an input context actually inherits from input device, because conceptually it provides a lot of the same functionality as an input device. It just builds on top of that. So these can all be set up from C++ code, both input context and input mappings, and there's some fairly thorough examples of how to do so in the input tests file in AZ Framework. So you can look at that if you need to know how to do any of this from C++ as an example. But more interesting, probably for the majority of people, is the ability to set up input contexts and mappings from the editor. And to do that, we use an input context component. I'm going to demonstrate how to do this by going back to the bunny Lua script that we set up in the previous section, and I'm going to set up some input mappings in the editor and then modify this script to listen for the mapped input instead of the hard-coded input channel IDs that I have here. So jumping back to the editor, I'm going to add an input context component to our same bunny entity. This could be added to any entity you want. Its lifecycle will be tied to the entity it's added to, following all the same rules as any other component. And the first thing that an input context needs is a unique name. So we'll call this the bunny move input context. There's a couple of advanced options down the bottom here that hopefully you won't need to worry about, but if you do, the tooltips and documentation should hopefully explain them in depth. But we mainly are here to set up some input mappings, which is what this array is. So we'll add our first mapping. That brings up this little dialog box here where you select which type of mapping you want to create. So out of the box, the engine provides OR and AND input mappings. Both of these just take a list of source inputs, and the OR, if any of those source inputs are active, the mapped input is deemed active, and with the AND logic, then all of the source inputs need to be active for the mapped input to be active. So for example, if you wanted an action to only happen if you're holding both the A and B button on a gamepad, you could set up a mapping using AND logic. But for this instance, we're going to use OR. So this shows us our input mapping here. Now the input mapping also needs a unique name, because an input mapping is an input channel. So we'll call this move left, will be our first one. And see, the name will update there to reflect the name that we've entered. Now we'll add our source input channel names. This will bring up some drop-down lists where you can select which input devices and which channels that belong to those devices you want to use in this mapping. So in this case, we are going to use the D-pad on a gamepad, or I should say, the same keys that we were using before on the keypad from the keyboard that were hard-coded in the Lua script. We want the navigation arrows, and now we want either of these two inputs to output a move left custom input channel name. Now moving back to the Lua script, I'm going to modify this to listen or poll for the mapped input instead of the hard-coded input channel IDs we have here. First off, I'll add a boolean saying whether to respond to mapped input instead of raw input. This is just the convenience, so we have an easy way to go back to the old behavior if we need. Below here, I'll say if we are responding to mapped input instead of raw input, then I'll override the left channel name as move left, and I'll actually set all of these up now. The right channel name is move right, move forward, and move backward. Now note that in the mappings I set up in the editor, I have currently only set up this mapping, but I'm still overriding all 4 input channel IDs. So once we now go back to the editor and we run, and now only the left will move it, but as you can see there, the channel name that it is outputting in the debug log is move left. And while you can't see what I'm actually doing, I am moving it with both the left keyboard navigation arrow and the left D-pad on gamepad. Okay, so now we have this set up. If we go back to the editor, and we'll add our 3 other mapped inputs to here. I'll collapse the mapping we've already added, just so it's a little easier to follow, and try and do this quickly to add 3 more. So move right, we want to be gamepad, D-pad right, or the keyboard navigation arrow right. And last 2 to quickly add. Move forward. Gamepad, D-pad up, or the keyboard navigation arrow up. And last one is move backward. And gamepad, D-pad down, or the keyboard navigation arrow down. Okay, now we'll run again, and now you can see we're getting all of those input mappings that we just set up printed out in the debug log, and the bunny is moving in response to both the keyboard navigation keys and the D-pad on the gamepad. Now, just to bring this full circle back to the start of the second section of this presentation, I'm going to flip this boolean back to false so that we go back to listening for input instead of polling for it. And I'm actually going to take out these debug logs just so we don't get the whole fire hose of all input events that get sent to this function. I'll add them instead inside the if statements. Just to demonstrate what's going on, back to the editor and enter game mode again, and you'll see there that when we're listening for input events, still behaves in exactly the same way with the mapped input as it was when we had the input channels hard-coded. Okay, thank you very much for watching the presentation. Appreciate you taking the time and hope you learned something from it. Apologies I can't be there in person to answer any questions, but if you have any, please head over to the SIG platform channel on the Open3D Foundation Discord, and I'll happily answer any if I can. Enjoy the rest of the conference, and thanks again for watching. Have a great day.